Good morning, class. Today we start the next chapter from the physics session. As you all know that we have already learned a chapter from the bio session and another chapter from the chemistry section. Now we will start a chapter from the physics session, and that is electricity. Okay, so firstly we start from the electricity. We have to know one thing, and what is electric current. So basically electric current can be defined as the amount of charge flowing across a conductor per unit time. Okay, that means a charge flowing per unit time is known as the electricity, and it is also defined as I is equals to watt q upon t, and q here denotes the quantity of charge and t here denotes what? Time. Okay, and the SI unit of charge is what? Coulomb, and the SI unit of time is what? Second. So we can say that electric current is also a unit, that is coulomb per second, or the SI unit which defines the electric current is ampere. Okay, that is the SI unit, and the SI unit of electric current is coulomb and contains 1 coulomb charge basically contains 6 into 10 to the power 18 charges, or the value of this. Now if you want to decide or to explain what is 1 ampere charge or 1 ampere current, so 1 ampere is the current flowing through a conductor if 1 coulomb of charge flowing through a 1 second. So basically if you want to define what is 1 ampere or the 1 ampere current, so that will be defined by what? 1 ampere is a current flowing through a conductor if the 1 coulomb of charge flows in it in 1 second. Okay, so we have to just define the term one by one. So that is about the things are getting there. Now 1 ampere is what? 1 ampere is none better than the 1 coulomb upon 1 second. Okay, now electric current is measured by the instrument which is ammeter, and it is always connected in the series in a circuit. Mainly there are two types of arrangement which are present in the circuit. First is parallel and second is series. So the ammeter is always connected in series combination. Now it is a diagram which is showing clearly, showing what? Electricity of a conductor flow through a conductor. Now it is the electric flow which is the negative to positive, and is a current flowing through a positive to a negative end. So it is about this. Okay, now we will just start the next topic from this chapter number, that is the electric potential and the potential difference. So basically what is electric potential and what is potential difference? So just suppose here that I having a ball and I have to throw the ball to the another home. So I have to just do a little bit of work to be done so that the ball just quickly go to the another place. So the work done to bringing that ball to one point to another point, that is the potential difference. Okay, now we will just draw a very complex here. We have just defining in a very proper way. So when two charges bodies are kept in contact, and the positive charge flow from higher potential to the lower potential, the potential on both the sides is equal, then the potential difference is zero. So basically what is potential? Potential is the work done in bringing a unit positive charge. I am talking about the electricity, so obviously I am talking about a charge here, because whenever electricity flows in a conductor, then should be the charge should be just formed or just to be transferred. So here the work done to bring, to just take a charge from one place to another place, so the one point to another point, that is known as the electric potential. So that one point will be A, then another point will be B. So basically what is the potential difference? Work done upon charge, because I am just taking a charge, and to bring a charge, what the work has to be done, that is known as the potential difference. So the ratio of both these twos are known as the potential difference, and which is also just defined by the V is equals to W upon Q. Here W denotes the work done and Q denotes the charge. Okay, so here also work done, the unit of work done is joule. You can know this, and you all know this. And charge, what is the unit of charge? That is the coulomb. So if you want to just describe what is potential difference of 1 volt, or the question is define 1 volt. Okay, 1 volt of potential difference. So how will you define this? If the potential difference of 1 volt is a potential difference when 1 joule of work done is done to move a charge of 1 coulomb from one point to another point. Okay, that is very easy. Then when the or you can say in a very common language also, if the work done is 1 joule and the charge through a conductor is 1 coulomb, then the potential difference is 1 volt. That is much easier way. Okay, we are just defining the terms one by one. When the work done is 1 joule, when the charge is 1 coulomb, then the potential difference is what? One potential difference is 1 volt. So this is about the potential difference. Okay, now potential difference is just measured in the voltmeter, and also it is just always connected in a parallel combination. Okay, is likewise in a meter it was connected in the always in the series combination, but in the case of the potential difference, or in the it can also be connected in the voltmeter. Okay, now we will just move through the third topic, that is the electric circuit. Now how does electric circuit look like, and how the symbols which are very necessary. Mainly in electric circuit is a continuous and closed path, you can see, and you can see here there is a bulb here, it is a ammeter here, it is a plug or the key here, and the cell here. Okay, now when the key is a closed or in the open condition, that will decide whether the current is flowing in a conductor or not. A cell at two ends which provide the current which is required by the circuit to just turn on the light or turn off the light. Bulb here, the light source also, and ammeter measured the current here. Okay, so there are the symbols here. First symbol, it is defining the electric cell, that's a positive and the negative end, and the battery is the none other than but the combination of cells as well. Now it is a plug key or switch. Now this plug key, if it is then this condition, it is in the open condition, that means no current is flowing in this, but the plug key or switch is closed, that means the current is flowing in this. Okay, now it is a way to just draw the electric bulb. Here is a resistant, which is the position of the flow of current. It is a rheostat, which is measures the amount of resistance. This is a symbol of ammeter, which is the capital A present in the center. It is a voltmeter, which present the capital V in the center. A wire joint, and the wire joint about the crossing. Now these are the some other symbols which are not very necessary to know about, but we have to just look at here where you just see these symbols, a meter and a voltmeter and a voltameter, galvanometer, which just shows the presence and the absence of current. Okay, the switch of light, filament lamp, crossing connected, and the other things also going here. Now this is the thing which have to be kept in mind. This is the connecting wire, this is the lamp or the light globe, this is the battery, this is the switch, and this is the electric motor, resistor, ammeter, voltmeter, electric bell. Okay, this is the way to draw the symbolize the structures or the other things in a very appropriate manner. Okay, so this is about the circuit diagram, about how this is, and this is about the Ohm's law. Ohm's law we will discuss in the next lecture, not today. So just revise yourself what we have taught today, and Ohm's law we will discuss in on the Monday's lecture.